Why are elements organized by period? Imagine a giant puzzle where each piece fits perfectly with its neighbors. That's what the periodic table does for elements. It arranges the building blocks of everything around us in a way that makes sense. But why do we organize elements by periods? Well, it all comes down to how electrons behave inside atoms. Atoms are made of a nucleus with protons and neutrons, surrounded by electrons. These electrons don't just float randomly. They occupy specific energy levels or shells. Think of these shells as layers of an onion. The first shell can hold up to 2 electrons, the second up to 8, and the third up to 18. When scientists look at the periodic table, they see rows called periods. Each period shows how many shells are filled with electrons for the elements in that row. Starting from the very first period, which has only hydrogen and helium, the electrons fill just the first shell. Moving to the second period, elements like lithium and oxygen have electrons filling to shells. As you go down each row, more shells are filled, and the properties of the elements change. This pattern helps explain why elements in the same period have similar behaviors. For example, as you go from left to right across a period, the number of protons and electrons increases by 1 each time. This makes atoms smaller, increases the energy needed to remove an electron, and affects how strongly they attract other electrons. This organization also helps scientists predict how elements will react. Elements at the start of a period tend to be metals, which easily lose electrons. Elements at the end are often nonmetals, which tend to gain or share electrons. Knowing where an element sits in the table tells chemists what kind of reactions it might participate in. For instance, sodium at the start of a period reacts strongly with water, while chlorine at the end forms compounds by sharing electrons. Organizing elements by periods isn't just about keeping things neat. It reveals natural patterns in their properties and behaviors. This makes it easier to understand how matter works and to develop new materials, medicines, and technologies. When scientists know an element's period, they can better predict how it will behave in different situations. It's like having a map that guides you through the complex world of atoms and molecules. So, the reason elements are arranged by period is to reflect how electrons fill their shells. This pattern shapes their chemical properties and helps us understand the universe's fundamental building blocks. It's a simple idea with powerful implications for science and everyday life.